Can you hear me, sir?
Yes.
Yes, sir. Stopping potential means expression is basically EV naught, but if we define it like stopping potential can be defined as the minimum negative voltage which is applied to the anode to stop the movement of the electrons. Or we can say that the maximum kinetic energy of the electrons is equal to the stopping potential or the stopping voltage.
Yes.
This EV naught equals to kinetic energy maximum K max.
Right. So it is the energy that is helpful for the stopping the basically stopping the electron.
Stopping the movement of the electron or the photocurrent.
Yes. Okay. So now let us discuss some graphs. These graphs are important. The experimental setup was like this. The experimental setup experimental study of photoelectric effect. Experimental study of photoelectric effect. Experimental study of photoelectric effect. So experimental setup, I have already told you that there will be a there will be a like vacuum tube and evacuated. That means vacuum is there and here glass is there. Quartz window or glass window. Transparent window basically. Then here there will be a photosensitive plate. Photosensitive photosensitive
Photosensitive plates.
photosensitive plate.
Yes, sir.
So when the light will incident, let's say from sunlight, when the light will incident on this plate, what will happen? Electrons will be ejected from here.
Yes, sir.
And the light energy or the energy incident here must be greater than the work function of the plate.
For function of the plate. Yes, sir.
So these electrons will come and there will be another plate, anode plate. This anode plate we can basically use variable voltage means we can provide positive potential also, we can provide negative potential also. So this plate, let's say anode plate, and from here we'll connect to the a potential variable potential. a variable potential will provide. So when this plate is positive plate, positive potential maintained at positive, then these electrons will come towards the positive plate, right?
Yes, sir.
These electrons will be coming towards the positive plate. So this is the experimental setup, and this glass must be evacuated. This is a evacuated glass tube. Sometimes in the board exam, this question comes. Explain or describe the experimental setup for this photoelectric effect. So you have to draw this diagram. Preferably draw it from the NCERT, right? So
Sure, sure.
this will be the evacuated glass tube. Evacuated glass tube. This is evacuated glass tube. So just can you see this pages? NCERT book.
Yes, sir, sure.
Okay. Right. So this is the experimental setup that we are discussing about. This is the experimental setup. Right. Look at the diagram carefully. Is the diagram clear?
Yes, sir, I have drawn this as well, sir.
Okay. So always follow most of the diagrams from NCERT.
Sure, sir.
So here you can see a quartz window or glass window.
Yes, sir.
Then these lights will come and these electrons will be ejected.
Sir, variable source is basically the commutator, right, sir?
Yes, this is a commutator. So this one you can, like, if will interchange. Suppose this and you will connect here. You see this source is positive, negative, right? Suppose this terminal is connected here. That means
Yes, sir.
this one is connected here, means this one will behave like a positive now. And also it is variable. This resistance, this rheostat is there like this. Okay. You can
Okay, sir.
you can change the this resistance value so that output voltage also will be different.
Yes, sir.
So the commutator is just to change the polarity. Commutator is used to change the polarity. Now we see that the emission of the electrons causes flow of electric current in the circuit. The potential difference between the emitter and the collector plate is measured by a voltmeter V, whereas the resulting photocurrent flowing in the circuit is measured by a microammeter Me. So there is a ammeter here. There is a voltmeter here. Voltmeter connected parallel to the circuit. Ammeter connected series in the circuit, right?
Yes,
So here we will measure the current and voltage. So photoelectric current can be increased or decreased by varying the potential of the collector plate A with respect to the emitter plate C. So this is a emitter plate from where the electrons are emitted. This is called emitter plate. This is also called emitter plate. Clear?
yes, sir.
The intensity and the frequency.
And A plate is the sir collector plate.
Yeah, A is the, this is a collector plate. Many fundamental questions are asked even in NEET also from this experimental study.
Yes, sir.
Now you see the intensity and the frequency of the incident light can be varied. So the source that is let may be sun or let may be some source of light, right? This is a source of light. So its intensity can be changed, and what can be changed? Frequency. Intensity and frequency, both are different things. What is intensity? Intensity means brightness, more bright, right? So this is called more intense light.
Sure, sir.
So intensity means, let's say one bulb is there in your room, light is coming. Now you put another bulb. What will happen? More bright your room will become.
Yes, sir.
That means intensity of your
Intensity is
increases.
increased.
So intensity increases. Does not mean that frequency increases. Frequency means whatever the, this is also a, let's say, bright white light. This is also a white light, right? Or this is a some particular color blue red light. This is also a blue light. So whatever the frequency, same bulb, let's say, same company, same watt, same bulb. So whatever the frequency of light coming in, frequency means number of waves per unit time, right? So whatever the
Right,
frequency
sir.
of light is coming from this bulb also have the same frequency that will be coming on. Now this frequency will not add up and it will not give a new frequency or more frequency. So the frequency of the light will remain same even if the intensity is increasing. Intensity means number of photon particles will increase. That's why the brightness will increase. Getting or not? The availability of more particles, photon,
Absolutely, sir.
that is the meaning of intensity. So that means we'll discuss more detail, and this is a very important concept that comes in the exam. That means if we are increasing the intensity, does it affect any way to the energy? No. Energy depends upon E equal to h nu. It depends upon frequency. It depends upon frequency, not intensity. So
Yes, sir,
energy of
sure.
the incident particle will depend upon energy of the incident particles will depend upon what? Will depend upon the frequency.
Yes, sir.
Depend upon frequency, not intensity.
Yes, sir, because intensity is defined by the availability or the number of photon particles.
Yes.
Sir, that's why if any alteration in intensity is observed, then it is not mandatory that frequency will be altered. Right, sir?
Yes. So frequency will not be affected by the intensity.
Intensity, right, sir?
So intensity you are increasing means number of particles incident on the plate is increasing,
Yes, sir, sure.
but not increasing their energy. Suppose
Yes, sir.
these particles are having 80 joule of energy. So even if the intensity is increasing, that means initially let's say 50 particles are falling on or getting incident on the plate. Now also 50 particles are getting incident.
Yes, sir.
Now you are increasing suppose intensity. So 50 to let's say 100 particles are getting incident on the particle on the plate, right? But
Yes, sir.
energy will remain same because same frequency.
Yes,
Even
sir.
if the intensity is increasing, it will not affect their energy. So as the
Sure, sir. Because with the energy also, if we write, hello, sir, can you hear me?
yes,
Yes, sir. Also, with the energy equation, if we include the number of photon particles, like we knew the equation E equals to h nu. There,
yes,
if n is the number of photon particles, then we can write it like E equals to n into h nu. Right, sir?
yes, yes,
And there also, it is not depending on the frequency.
yes. So uh, here, if the intensity is increasing, so what will happen? The number of particles will increase, and as a result, what will happen? Number of electrons that are coming out will increase. If number of electrons that are coming out will increase, that means current will increase.
Yes,
Current
sir.
will increase. Because current is what? Number of electrons per unit time.
Yes, sir. Absolutely.
So current will increase. So
Sure,
intensity
sir.
if it is increasing, current will increase. But this current which is coming out, these electrons which are coming out, they will be with the same energy initially, means their half mv square, their kinetic energy will be same as before. Intensity increasing does not mean their kinetic energy will increase. Their kinetic energy will increase when we are increasing the frequency of the source. So for source frequency, if it will increase, what will happen? Initially, let's say it is having energy 80 joule. Now you are providing more high frequency light. So high frequency light means let's say the energy becomes 120 joule now. Initially it was 80 joule. Now work function is constant, right? That is the surface energy. So surface energy is let's say
Yes, sir.
20 joule or 30 joule. So
Mhm.
80 minus 30, initially the electrons which are coming out from the plate are having how much energy? 50 joule.
50 joule. Yes, sir.
Now these electrons will have more amount of energy because 120 joule is the incident energy and 30 joule is the surface energy. That is your work function.
Yes,
So
sir.
how much now the electron will have the energy? Electron will have the energy now 90 joule. So your kinetic energy of the electrons will increase. What will happen? Kinetic energy of the
Kinetic energy of the electrons will increase, sir.
kinetic energy of the electrons will increase. So kinetic energy of
Yes,
the
sir.
electrons will increase means kinetic energy of the electrons will increase means we need require more stopping potential to stop them, right? We require more stopping
Absolutely, sir.
potential to
Absolutely.
stop them. So these concepts that we have discussed are also now we'll discuss in terms of graphs, right? That intensity versus current, right? So all these things we'll now study in like graphs. These are very important
Sure, sir.
for exam. So you see that as the potential difference V between the emitter C and the collector, we can use the experimental arrangement and study the variation of the photocurrent with intensity of radiation, frequency of the incident radiation, and the potential difference between the plates A and C, the nature of the materials of plate C. So all these things we'll discuss in graphs, right? That how it will affect the photocurrent. That means the current that is coming out of the plate. So the question comes generally this graph every year one graph generally comes that or
Yes, sir.
a graph will be given, you have to analyze this, that how what will happen. So this is a very important part of this chapter. Light of different frequency can be used by putting the appropriate colored filter or colored glass on the path of the light falling on the emitter C. This intensity of the light is varied by changing the distance of the light source from the emitter. Okay. So this question also one year came. How will you
Sure,
change
sir.
the intensity? Okay. How will you change the intensity of the light source? Given a light source, you are given a light source. How will you change the intensity? So you can write that by changing the distance, because if a bulb will be like I told you that two bulb will glow, then intensity also increase. But but instead, if one bulb will glow, your plate is here. So the number of photon particles it was getting, if you take it to larger distance, so less number of photoelectrons photon it will get, because it's spreading up, right? So it will not get all the photons. Some part of the photons it will get. Let's say initially when it was closer, it was getting 100 numbers, but it will be away. Let's say it will get 80 or 70 like that. So less number of photons it will get. That means the intensity of the light on the photosensitive plate is now less than the initial one when it was closer. That means
Yes, sir.
distance is increasing, you are reducing the intensity. Distance is increasing, you are reducing the intensity. Clear? Now we'll one by one we'll discuss. Similarly, how will you change the frequency? You can change the frequency by using filter or a different color. Suppose in front of white light, you will use a filter which can only pass the red light. Let's say it's like a polarization, right? Only red color is allowed to pass, other color will not pass. Okay, you are using a filter like that. So these filters are used in different like events or the different like shows, right? Stage program. We put a different color of light to the performance.
Yes, sir.
So actually this they have different filters, right? So that red will come, blue will come out. Okay. So when blue will come out, it
Absolutely,
will
sir.
be different wavelength, and different wavelength means it will have a different frequency, right?
Yes,
Different
sir.
wavelength means different frequency. So the intensity of the light of different frequency can be used by putting appropriate colored filter or the colored glass in the path of light falling on the emitter C. ठीक है, तो ये you can uh, note it that how you change the frequency by using different colored filter or passing the light through a different filter, or different colored light can be allowed to pass, so that we can change the incident light frequency. The first graph is effect of intensity of the light on the photocurrent. We have already discussed it. The effect of intensity of light on the photocurrent. So what happens? Intensity increases means number of photon particles that are getting incident, or those are incident on the photosensitive plate, that is increasing. So as a result, what will happen? Number of electrons that is coming out from the plates, they will increase. So number of electrons
Yes, sir.
increase means current will increase, because current is Q by T, number of charge per unit time. So if more number of charges are coming out, so current will increase. So that means intensity is increasing, current also, photocurrent also will increase. Why photocurrent? Because photons are responsible for making the electrons out of the photoplate. So that's why it's called photoelectric current, right?
Yes, sir.
So it will be directly proportional. Like more intense light, more number of charges, electrons will come out from the surface. So the graph will be directly proportional. The graph will be directly proportional. So it is intensity versus current, photocurrent. So the graph will be like this, straight line. Clear?
Yes, sir. Straight line and increasing.
Yes. And also, this implies that number of photoelectrons emitted per second is directly proportional to the intensity of the incident radiation. The statements are important, okay? Sometimes assertion region question also comes from it.
Absolutely, sir.
So this implies that number of photoelectrons emitted per second directly proportional to the incident radiation. Then effect of potential on photoelectric. Effect of potential on the photoelectric current. So let's see how potential is affecting the photoelectric current. So I have told you that in that experiment that we have discussed, in the experimental setup, here the light was incident on the plate. Now these lights will emit the electrons. The electrons will come like this. There is a positive plate here. The electrons will move towards the positive plate, anode, and we are providing a positive potential to it. Electrons will come towards it, right? So what is our graph? Our graph is variation of photo
Yes, sir.
with the collector plate potential. So this is your collector plate potential. Here is the collector plate for different intensity of incident radiation. For different intensity of the, let's take first one intensity. Now we'll change the intensity and we'll see. So what will happen? Variation of photo collector photocurrent with the collector plate potential. Now let's say I1 is the intensity of the light which is falling on the photosensitive plate. Now these electrons are coming. So for I1 intensity, let's say 100 electrons are coming out. Getting? So these 100 electrons which are coming out, they
Yes,
will
sir.
carry current, and this is a positive potential. Now, if we'll increase the potential, what will happen? These electrons, more electrons will come out. So current will increase. Getting or not? Current is increasing like this.
Sure, sir. Sure.
Current is increasing. So while you are increasing the potential, current is increasing. Now, let's say 100 electrons are there. Now, after you make this positive potential, let's say 20 volt, what happens? All the 100 electrons are moving to the plate. There is no other electrons available. Or you can say, when the terminal is maintained at 20 volt, then suppose from this plate per second, 100 electrons are coming out. So all the 100 electrons per second are absorbed or just coming and getting flowing into the circuit. That means no extra electrons. Let's say out of 100 you are 80 electrons it can take, then 20 extra electrons are also in this space, right? So as you increase the voltage, what will happen? Gradually the current
Yes, sir.
increase. But when it is when your potential is, let's say, at a level where all the electrons are dragged or come to the circuit, flowing through the circuit, then no more current will increase. Here emitter is there, emitter reading will be constant. It will not enhance. It will enhance the current. It will not enhance the current further. Getting? So current will become saturated. Photo current
Yes.
will become saturated for the intensity I1. And V0 is the negative potential, because when it's a stopping potential, minimum potential that all the electron can be stopped coming. So you will maintain a negative potential, and these electrons have the energy, let's say whatever the energy, you want to stop them. So you have to provide a negative potential to them. You have to provide a negative potential to them. Now what will happen? Now you are putting a different intensity light, increasing the intensity to I2. So what will happen? Number of photon particle will increase. So the number of electrons will increase. And for that, number of electrons, let's say 100 electrons are there. Now 120 electrons are coming in. So you need more voltage to collect all the electrons from there. So let's say you require 25 volt for that, so that all the electrons will be dragged, right? You need more potential
Yes,
because
sir.
more number of electrons are there. So to collect them faster, you need a little bit higher potential. So your graph will increase, and after at a potential, all the 120 electrons will be coming to the circuit, collected to the in the collector plate. So it will now get saturated for a new intensity I2, and I2 is better than I1. But it will have the same stopping potential. Why? Because energy of the electrons is same. The frequency of the incident light is same. I1 and I2 intensity is different, but their incident frequency is same. First case and second case. That's why the electrons coming out is the same energy. The same energetic electron, if they are coming, now to stop them, you require the same stopping voltage. So V0 for stopping potential for both the cases is same. That's why all are coming from the same stopping potential. Because to stop them, you require the same voltage. Is it clear?
Yes, sir.
The stopping potential, if you are increasing the intensity, so what will happen? The current will increase and it will be saturated at a higher potential. But the stopping potential, to stop the electrons, you require the same voltage as before, because the energy of the electron that are coming, even the number is more, but energy is same. Each electron is having same energy, right?
Yes, sir.
Energy is not increasing because frequency of incident light we are not changing. So that's why if you will take a third intensity, more higher intensity, you will get a higher, like, or more current will be there. Photo current will increase, right? But after a
Yes, sir.
particular time, it
Sir,
will stop.
here I3 is can be called as saturation current, sir.
No, I3, these are intensity for a different intensity. I1 and I2 are
Okay, sir.
the intensity.
But sir, at I3
Not
intensity,
current.
can we get the saturation current?
Saturation current is from here to here, this region. This is the current, photo current, and this is collector plate potential. So even if you are increasing the collector plate potential, let's say 25 to 27 to 30, even if you are increasing the voltage, but nothing will happen. The current will remain same because all 120 electrons are absorbed, right? No more electrons are
Yes, sir.
available. So
Mhm.
current will not increase. Current is number of electrons only. So number of electrons
Yes,
finished up. When it is 25 volt only, it's finished up. All the space is clean. All electrons are now flowing, right? Again, next second, again 120 will come, it will all absorb. Now, if you will increase further the voltage here, collector plate potential, if you will keep on increasing, but still you cannot increase the current because now no extra electrons available in the space to flow, right?
yes, sir.
So it
Sure.
will just be constant even if you are increasing the 30, 35, even if you are increasing the collector plate potential, but still what will happen? You will not able to increase the current. You will not able to increase the current. Clear?
Clear, sir.
Right. So this graph is also very important for your exam. And this line is also important. For a given frequency of incident radiation, the stopping potential is independent of the intensity. कुछ भी intensity हो जाए, the stopping potential will be same because frequency is not changing. So energy of the electrons which is coming out of the plate is same. That's why to stop them, you do not require different stopping potential. One stopping potential, the same stopping potential will help for all the intensity of the light. Only numbers are more coming, but that doesn't mean, but the energy, they have the same energy, right? So to stop them, it can be with the same stopping potential, they can be stopped, right?
Yes.
In other words, the maximum kinetic energy of the photoelectrons depending on the light source and the emitter plate material, but independent of the incident radiation. So energy of the electron that are coming out of the plate, that depends what? Two things that depends upon. One is the plate work function of the plate. If the work function is less, then even if you are incidenting same frequency or same energetic light, but the electron energy or the speed will increase, right? Why? Because it require less amount of energy now. Suppose the incident energy is 80 joule, this is having 30 joule. Now another plate, let's say the incident light is same 80 joule, but the plate potential, that is work function, is let's say 20 joule. So which case more energetic electrons will come out?
Yes, sir. Certainly.
Second, where the difference is more, right? Even if the same amount, same energy, light, same energetic or same energy means same frequency. Actually, frequency is energy, right? E is equal to h nu. So if the same frequency of light is incident on two different photosensitive plate, the one which have lower work function will release more energetic electrons. Getting the statement? So the maximum kinetic energy of the
Yes, sir.
photoelectrons depends on the light source and the emitter plate potential, but independent of the intensity. So emitter plate potential के ऊपर डिपेंड करता है और किस पे डिपेंड करता है? Light source. Light source means the energy of the source.
Energy of the source. Yes.
More energetic source is there, then also more energetic electrons will come out. Or if the work function of the plate is also different, then also different energetic electrons will come out. Kinetic energy of the electrons will be different, right?
Yes, sir. So, sir, means work function का value अगर कम होगा तो then speed of the electrons will increase, right?
Yes, work function कम हो जाएगा तो speed of the electrons will increase.
Yes,
Same,
sir, sure.
suppose same energy light incident on the plate. एनर्जी को सपोज हम लोग टच नहीं कर रहे हैं, जितना था उतना ही है, प्लेट का चेंज कर दिए, जिसका कम वर्क फंक्शन हो उससे ज्यादा एनर्जेटिक इलेक्ट्रॉन्स विल कम आउट. Then the third graph, which tells the effect of frequency of light of radiation on stopping potential. So this is very simple. If you increase the more in, if the incident frequency will increase, that means energy is more. And if more energy is there, what will happen? More energetic electrons will come out. And if more energetic electrons will come out, you need more stopping potential, right? Higher stopping potential to stop them. So your V stopping potential will increase. So here graph is photocurrent versus collector plate, and for different incident, different frequency of incident radiation. Different frequency of incident radiation. So for different frequency, what will happen? To stop, let's say your new one, a frequency, and new 3 is greater than new 2 is greater than new 1. So frequency of third radiation is greater, highest. So stop this, to stop this electron, right? Because higher energetic electrons will come out if the frequency of incident light is more. So you need a greater stopping potential. So stopping potential, you see V03 is more. V3 is this potential, stopping potential is more. Then new 2 will have a different stopping potential. New 1 will have another different stopping potential, right? But the number of electrons will
Yes,
not
sir.
change. The same amount of electrons will come out because you are not changing the intensity. So after some time, what will happen when you are increasing the potentials? So these electrons will come and pass through this or attracted to the potential. Now beyond a certain point, because frequencies are different, even though frequencies are different, it will not help to increase the current, right? Initially the current will increase gradually, but after a certain time, even if you are increasing the frequency, more energetic electrons will come out, but current will not increase. Getting current, because number of
Absolutely, sir.
electrons coming out is same. It's not more than the, if you are increasing the frequency, more number of electrons will not come out. It's the same. Let's say 120 it was initial, then again 120 will come. So that's why after a particular your voltage, right? All the different frequency of light, or even if you are using the photo current, the current reading in the ammeter will become same, even if you are increasing the collector plate potential. So whatever the electrons coming out will be same in all the cases of different frequencies. So it will be saturated and all three will mix and they will have the same saturation current. So this is the
Yes, sir.
This is the graph for different frequency of light, right? And its effect on photocurrent. This is the last graph. That is the variation of stopping potential with frequency for a given photosensitive material. So this is the graph versus frequency versus stopping potential. So obviously, if the frequency will increase, right, then stopping potential also will increase. But this B0 is the threshold frequency. So till the threshold frequency, electrons will not come out. So you do not require any stopping potential. Beyond the threshold frequency, let's say plate work function is, let's say, 20 joule. Now, if your incident frequency energy is less than 20 joule, let's say 10 joule, so nothing will happen, no electrons will come out. So you do not require a stopping potential. So up to V0, it's 0, like this. You see the line which is just on the axis. That means 0 stopping potential you require. Now, beyond the this mu 0 is the threshold frequency. That is the work function frequency of the material. Now, if your frequency will be incident frequency is greater than the like minimum frequency or threshold frequency of the material, so what will happen? Electrons will start coming out, and these electrons, when it will start coming out, you require a stopping potential in the collector plate. To negative potential you require. So the stopping potential will increase as you increase the incident frequency, and will keep on increasing the frequency of the incident light. The stopping potential will increase. The stopping potential will increase, and let's say this is for a metal A. Now another metal, different photosensitive plate, that means different, it will have a different your threshold frequency or work function. So as the threshold frequency is different, it will start emitting electron after a certain minimum frequency, that is the threshold frequency, right? And this threshold, after beyond a threshold
Yes, sir.
frequency, electrons will start coming out, and then you will get this graph. Like you will require stopping potential. So stopping potential will increase as your incident radiation frequency is increasing, because more frequency, more is the energetic particles, and more is the energetic particles, more frequency, more stopping potential you require to stop them, right?
Yes, sir.
So So sometimes in the exam it is given like this, question given like this. क्वेश्चन कैसे देता है ना, ऐसे तुम्हें दो तो ग्राफ दे देगा, लिख देगा मेटल ए, मेटल बी, पूछेगा कि मेटल ए या मेटल बी, किसका वर्क फंक्शन ज्यादा है? किसका वर्क फंक्शन ज्यादा है? ये दे देगा फ्रीक्वेंसी वर्सेस स्टॉपिंग
ओके सर।
पोटेंशियल ग्राफ। तो किसका वर्क फंक्शन ज्यादा होगा? whose work function will be more? Whose work function is more in this case?
Sir,
मेटल।
in this case, yes, sir.
वर्क फंक्शन किसका ज्यादा होगा? वर्क फंक्शन मींस थ्रेशोल्ड फ्रीक्वेंसी।
Yes, sir, absolutely.
सो
सर
थ्रेशोल्ड
मेटल
फ्रीक्वेंसी
ए का ज्यादा होगा सर।
किसका ज्यादा होगा?
मेटल ए का।
मेटल का क्यों ज्यादा होगा? इसका तो इतना ही है थ्रेशोल्ड फ्रीक्वेंसी, उसके बाद इलेक्ट्रॉन रिलीज होना स्टार्ट हो गया, तभी तो
यस
पोटेंशियल आ रहा है।
सर, मेटल बी का होगा सर,
मेटल
यस।
बी का ज्यादा है, थ्रेशोल्ड फ्रीक्वेंसी ज्यादा है, मतलब वर्क फंक्शन ज्यादा होगा।
यस
मेटल
सर।
बी का थ्रेशोल्ड फ्रीक्वेंसी, क्योंकि इतना फ्रीक्वेंसी के बाद, इतना फ्रीक्वेंसी, ये इंसिडेंट फ्रीक्वेंसी है ना,
यस सर।
इंसिडेंट फ्रीक्वेंसी इंटू एच इक्वल टू तुम्हारा एनर्जी। तो इतना एनर्जी डालने के बाद उसमें इलेक्ट्रॉन रिलीज हुआ, इलेक्ट्रॉन रिलीज होने से तो स्टॉपिंग पोटेंशियल, उसको स्टॉप करेंगे, और
यस
स्टॉप
सर।
करने के लिए स्टॉपिंग पोटेंशियल चाहिए। यहाँ तक इलेक्ट्रॉन निकल ही नहीं रहा था, तब स्टॉपिंग पोटेंशियल जीरो था। तो इतना फ्रीक्वेंसी तक
यस
नहीं
सर।
निकल रहा था, मतलब इसका ज्यादा एनर्जी चाहिए वो प्लेट को, तभी इलेक्ट्रॉन निकल रहा है। दैट मीन्स प्लेट का वर्क पोटेंशियल ज्यादा है, एच न्यू जीरो ज्यादा है, एच न्यू टू इज मोर, और एच न्यू बी इज मोर देन एच न्यू जीरो ए। ठीक है,
यस सर।
क्योंकि इसका न्यू
Sir,
जीरो,
frequency of the incident radiation is basically the threshold frequency.
इंसिडेंट रेडिएशन थ्रेशोल्ड फ्रीक्वेंसी नहीं ना, इंसिडेंट रेडिएशन के बाद जब इलेक्ट्रॉन
Yes,
रिलीज,
sir. After that, yes,
हाँ,
sir. After release of the electron, then threshold frequency will be.
यस, तो मतलब इस प्लेट का सपोज थ्रेशोल्ड फ्रीक्वेंसी हमें पता नहीं है, वी डोंट नो द थ्रेशोल्ड फ्रीक्वेंसी ऑफ दिस मटेरियल। सो हम लोग क्या कर रहे हैं ना, इसमें इंसिडेंट लाइट गिरा रहे हैं। तो पहले 10 जूल का गिरा है, इलेक्ट्रॉन नहीं निकला। फिर 12 जूल का इंसिडेंट किए, फिर भी इलेक्ट्रॉन नहीं आया। फिर 14 जूल का किए, फिर इलेक्ट्रॉन आना चालू हुआ। उसका मतलब इसका वर्क फंक्शन जो है 14 जूल का आसपास है ना, 14 जूल का आसपास है। मतलब 12 जूल तक वो तो एब्जॉर्व कर लेते, उसका इलेक्ट्रॉन का बॉन्ड ब्रेक नहीं हो रहा था, और इलेक्ट्रॉन को सफिशिएंट एनर्जी नहीं हो रहा था इलेक्ट्रॉन को निकालने के लिए सरफेस से। गेटिंग ऑन? तो अप टू वर्क फंक्शन, दैट इज द
Yes, sir.
threshold energy. So up to this threshold energy, electrons will not come out. Up to this threshold energy, electrons will not come out. थ्रेशोल्ड एनर्जी से ज्यादा एनर्जी जब हम लोग, इसका सपोज थ्रेशोल्ड एनर्जी 14 जूल का है, तो 14 जूल से ज्यादा जब हम लोग डालेंगे एनर्जी एच न्यू, तब होगा इलेक्ट्रॉन आएगा। तो 14 जूल से इलेक्ट्रॉन आना जस्ट चालू हुआ, मतलब हम लोग बोल सकते हैं इसका थ्रेशोल्ड एनर्जी जो है 14 जूल है, और बोल सकते हैं वर्क फंक्शन इज 14 जूल। तो उससे हमारा ये है तुम्हारा वर्क फंक्शन। इंसिडेंट लाइट से हमें इनडायरेक्टली निकाले कि इसका वर्क फंक्शन कितना हो सकता है, क्योंकि इधर से इलेक्ट्रॉन निकलना चालू हुआ, तब यहाँ तक नहीं निकल रहा था, मतलब ये वर्क फंक्शन है उसका। ठीक है, तो these are the graphs, and these graphs, out of these graphs one
Yes,
graph
sir.
generally comes in the exam। ठीक है, ये सब स्टेटमेंट बहुत इंपॉर्टेंट है, इसको सब पढ़ लेना, वही हम लोग ऑलरेडी डिस्कस कर दिए। For a minimum cutoff frequency, the incident radiation is called threshold frequency, below which the emission of the photoelectrons, no emission of the photoelectric electrons takes place. Emission of photoelectron takes place. मतलब इसका सपोज 14 जूल का है थ्रेशोल्ड एनर्जी या वर्क फंक्शन, दोनों सेम चीज है। तो हमें 14 जूल से कम एनर्जेटिक लाइट डालेंगे या कम फ्रीक्वेंसी वाले लाइट डालेंगे तो इलेक्ट्रॉन्स नहीं निकलेगा, नो फोटो इलेक्ट्रॉन एमिशन इज पॉसिबल,
ये
होगा
सर
नहीं।
उससे ज्यादा होना पड़ेगा सर।
इसमें ज्यादा एनर्जी देना पड़ेगा उसका प्लेट का एनर्जी से। Above this threshold frequency, the stopping potential and equivalently maximum kinetic energy of the photoelectrons increases linearly with the frequency of the incident radiation but independent of its intensity. Intensity पे depend नहीं करता है and increases linearly with the frequency of the incident radiation. ठीक है। Photoelectric emission is an instantaneous process without any apparent time lag, that is 10 to the power minus 9 सेकंड और लेस। मतलब इंस्टेंटेनियस हो जाता है, बहुत कम टाइम। ये गिरेगा उसके बाद वो सोचेगा उस निकलने के लिए, तो सोच के निकलेगा, ऐसा नहीं, इंस्टेंटेनियस हो जाता है। गिरेगा, एनर्जी मिला, ब्रेक बॉन्ड ब्रेक हो गया और सरफेस से एनर्जी सफिशिएंट मिल गया, वो निकल जाएगा फट से, स्पॉन्टानियस जैसे। इवन व्हेन द इंसिडेंट रेडिएशन इज मेड एक्सट्रीमली एक्सीडिंगली डीम। तो एक क्वेश्चन करते हैं। सीबीएसई 2017 का क्वेश्चन आया। The study of the photoelectric effect, the graph between the stopping potential and frequency of the incident radiation of two different metals PQ is shown below। तो ऐसा करके ग्राफ दिया हुआ है, जो कि हम लोग अभी अभी डिस्कस किए। ग्राफ ऐसा है, फ्रीक्वेंसी वर्सेस स्टॉपिंग पोटेंशियल का ग्राफ दिया हुआ है, और मेटल बी का ऐसे दिया हुआ है, ये मेटल पी, ये मेटल क्यू, और ये दिया है 0.4, ये 0.6, और ये इसका फ्रीक्वेंसी क्या है, जो भी नंबर लिखा गया उसके साथ मल्टीप्लीकेशन 10 to the power 14 हर्ज की है, और ऊपर का यूनिट क्या है, वोल्ट की है। ऊपर कितना है, ये 2 है, ये 4 है। डिटरमिन व्हिच ऑफ द टू मटेरियल्स हैव हायर थ्रेशोल्ड फ्रीक्वेंसी। व्हिच ऑफ द two materials, two metals have higher threshold frequency। थ्रेशोल्ड किसका ज्यादा थ्रेशोल्ड फ्रीक्वेंसी होगा?
सर क्यू का।
Two metals have the higher threshold frequency।
सर क्यू का होगा।
हम्म,
सर am I audible sir?
हाँ, यस, किसका होगा ज्यादा?
Sir, Q will be having the higher threshold frequency.
यस, so आंसर इज क्यू।
Yes.
Second part of this question, determine the work function of the metal which has greater value। Determine the work function of the determine the work function of the metal which is greater value. Determine the work function of the metal which is greater value.
Yes, sir. Calculated.
Determine the वर्क फंक्शन ऑफ द मटेरियल मेटल विच इज ग्रेटर वैल्यू। तो वर्क फंक्शन का फॉर्मूला क्या है, फाई इक्वल टू एच न्यू जीरो। तो एच न्यू न्यू जीरो कितना है इसका 6, ज्यादा किसका है इसका, तो इसका कैलकुलेट कर लिए बोल रहा है। ठीक है।
Yes, sir. Doing this, sir.
हाँ, तो फाई इक्वल टू एच न्यू जीरो, एच कितना है 6 इंटू 10⁻³ माइनस 34 इंटू न्यू जीरो कितना है 6 इंटू 10⁻14, राइट। ठीक है, तो मल्टीप्लाई कर दो, जितना होगा वो जूल। ठीक है, इसको 6 ही पकड़ लोगे, सपोज 36 अप्रोक्स इंटू 34 प्लस 14 चला जाएगा 10⁻20, राइट, -20। ठीक है, लास्ट पार्ट इज
सर ये आ रहा है 39.756 इंटू 10⁻⁻20 जूल।
राइट।
यस सर।
नेक्स्ट पार्ट ऑफ द क्वेश्चन इज फाइंड द मैक्सिमम काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन एमिटेड by the light of frequency incident light of a frequency 8 इंटू 10⁻14 हर्ट्ज। तो इंसिडेंट लाइट का फ्रीक्वेंसी कितना दिया 8 इंटू 10⁻14 हर्ट्ज। बोल रहा है कि वो लाइट गिरने से जो क्यू सेम मटेरियल बोल रहा है, मतलब क्यू के बारे में डिस्कशन हो रहा है, हाईएस्ट जिसका फ्रीक्वेंसी थ्रेशोल्ड है, तो बोल रहा है उसी का कितना काइनेटिक, जो इलेक्ट्रॉन निकलेगा उसका काइनेटिक एनर्जी कितना होगा। What will be the kinetic energy of the electrons emitted by the same metal if the frequency of 8 into 10⁻14 hertz incident on the metal? So what will be the kinetic energy of the electrons? That will be
Sir, answer will be 13.252 into 10⁻⁻20 joule.
okay. So basically you will use the formula K equal to H nu minus H nu naught, right? Or H nu minus nu naught.
Yes, sir.
So H is 6.6 into 10⁻⁻34. Nu minus nu naught is 8 into 10⁻14 minus nu naught is 6 into 10⁻14. This is the nu naught value, right? So you should get whatever, you should multiply and get this number 34 into this is
Yes, sir.
10⁻14 common, so 8 minus 6 is 2 into 10⁻14. So again it will be 13.2 into 10⁻⁻20, right? So you are getting this number.
Yes, sir. 13.252 into 10⁻⁻20.
Okay, fine. Okay, you try some more questions, we'll discuss. further in the next class. Okay.
Sure, sir.
Okay.
Sir, are you available tomorrow, sir?
Tomorrow, yes, tomorrow I'll be available. Yeah.
Okay, sir. Online, you're available, right, sir?
Yes.
Sir, can you please let me know the timing, sir?
Similar time will start tomorrow.
Okay, okay. 9 or 9:30 के आसपास, right, sir?
Yes, yes.
Okay, sir. Okay. Okay. And sir, one more thing, sir. Are you available this Saturday offline, sir?
Saturday 4 p.m. 4 or 4:30 I'll be available.
Mm, sir, actually means my chemistry class will be ended like around 7 p.m. So after that possible, sir? Like
Offline.
from 7. Yes, sir, 7:30 or 8.
7:30 you can come.
7:30 or 8 I can come, right, sir?
Yes, yes.
Okay, 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 sir. And Sunday morning, sir?
Sunday morning,
Early in the morning.
early you can come. By 9 I can
From
leave.
Okay, okay, sir. Now from 9 I am also having tuition, so from
You
6:30
can
we
come
can do, right,
6:30
sir?
to 8:30 you can come.
Sure, sir, sure. Thank you so much, sir. Thank you, sir.